Hello and welcome back to this next session from the A4Q Testing Summit 2026. We have now lunch here in Europe. Maybe you have already evening or something in the morning, but we are here just at lunchtime. And I welcome here Sagar Joshi at the stage. He is a software testing professional with experience over 16 years in automotive and enterprise software domain. So a real expertise now for the next topic. And he will talk about why testing AI system breaks traditional test strategies. Before we start, I want to mention, if you like Saga's speech, you can vote for him at the best speaker and presentation nomination here via the QR code. And please also use the chat during the speech to ask questions that we can use these questions afterwards in the Q&A session with Sagar. And now, Sagar, the stage is yours. Enjoy and have fun.
Yeah, thanks, Rachel, for this introduction and for sharing the stage. Let's get started. So today I'm going to talk about the other part of AI. So I see many talks around using AI to optimize the testing efforts. But in this talk, you will see I talking about uh, how to test the AI-based applications and how it's gonna be different. So what strategies you need a different so that you test the AI-based applications well. Okay, so let's get started with a deep dive into understanding the real-world AI failures. Now, we are not going to discuss these failures to understand the limitations of AI or to criticize the AI, but we will be learning these failures to understand how the testing is going to be challenging when we are testing the AI-based applications. And yeah, so when there are challenges, obviously there are opportunities. So we will be understanding these failures to understand what could be the new opportunities in the market, okay, and what could be the different approaches, the strategies what we should apply, and more importantly we will understand how the traditional test strategies may not valid when you're testing a AI based applications. So let's get started to a deep dive into understanding the AI failures. So this is one of the most widely reported failure, okay, so which coming from the Amazon's attempt to automate the recruitment process. So the goal was simple, to build a AI system that could screen the thousands of job applications and make make a recommendations for the best candidate. But here what happened is, after a few years, Amazon discovered that the system consistently downgrades the CVs which contains words like a woman. Now, for example, if the CV has a mentioning about the women's chess club camp captain, or maybe a woman intake conference organizers, like this words, then it was underrating these kind of a CVs. Now, why this was happened? Because the model was trained for the past 10 years of historical data, and those past historical data had these patterns. So even AI learned that the male applications are the good candidates, and so it was recommending the male profiles over the female profiles. So here the problem was with the input training data. So if your input training data is biased, AI learned from these biases, and it has reflected these human biases when we try to create a models, and it has amplified these biases. So for us as a tester, it raises an important question: how do we test the data? Not just functionality, right? Because here the algorithm worked perfectly. What what went wrong? The input data. Okay, so it just learned the wrong lessons from the input data. Okay, to moving on, there is a UCAS admission bias. Now, this is a UK's university admission system, and the this in this investigation reveals that the application from the black students were significantly more likely to be flagged for additional scrutiny. So it compared to those of white students, the black students' applications were more flagged for a scrutiny or further investigation. So here, the AI wasn't explicitly racist, but it simply learned the wrong patterns in making decisions. So it looked for the anomalies in the applications, in the data, and because it was trained on the data from the schools and the regions and from a uh, uh, different patterns, and it's mistook that the diversity for the deviations. So now here is the key point. The system technically worked as designed. It detected the anomalies accurately, but ethically it has failed. So this teaches us that AI can write mathematically, it can be right, but it could be wrong morally. And that's where testers need to step in to question not just whether it works, but it works fairly or not. The another failure what I would like to discuss is the Google photo. So here, the Google photo used AI-based image recognition, and this system automatically tags the photos. But the system was, yeah, so it was labeling incorrectly for the black people. So you see in the image, it has labeled a black people as a person as a gorilla, right? So it wasn't intentionally, okay, it wasn't maliciously, but it was the result of poor trained models. So model that doesn't have enough diversity in their trainings, so probably it might have not been trained on the enough images, or the training images not have enough representation of a different diversity. So Google had to issue an apology and disable this feature altogether. So this failure highlights another challenge, the coverage. So when we test AI, it's not enough to test the functionalities. We must also test the representation. So has the AI seen enough of the real world to make a fair decisions, the accurate predictions? The self-driving car incident. Okay, so in 2018, a self-driving car was being tested by Uber, and it has killed a pedestrian. And the AI system failed to recognize the person crossing outside the designated crosswalk. And technically, the model hadn't been trained for that specific scenario. So when it saw a pedestrian, it kept switching its classification, first as an object, then as a bicycle, then as a false alarm, right? So here the tragedy was that not about the software error, but it was about the contextual understanding. So AI doesn't trust, AI doesn't truly understand uh, its recognized patterns. So when patterns do not fit the training data, AI simply gets confused. And this shows how testing for the real world uh, variability, not just controlled test cases, becomes crucial. I have one more example. So the Apple card credit limit controversy. Okay, so this is again a failure with the Apple credit card algorithm. So multiple users reported that the women's were considerably given a lower credit limits than that of a man, even with having a shared accounts and identical financial history. The company says that algorithm doesn't use any gender as an input, but when it has learned the bias from other parameters, probably from the income, the purchase behaviors, the historical credit usage. So many times the biases may not be visible. It may be hidden. So biases doesn't always announce on itself, and it's hidden in a correlationship and the context, which makes testing must evolve to detect the indirect discrepancies. Okay, so one of the most interesting type of AI learning is a reward hacking. Okay, so reinforcement learning, and this reinforcement learning may trigger a reward hacking. So, what is a reward hacking? So, in case of a reinforcement learning, the AI learns how to receive the maximum rewards, and yeah, so it achieves the goal, but not in the right way, not with the right intentions. So maybe let me explain some of the examples for this. So you can see the YouTube recommendation. The goal is to increase the engagement. Now, to increase the engagement, the YouTube recommends you the extreme videos, the controversial videos, the sensitive videos. Yeah, so it's helping you to increase the engagement, but not in the right intentions. You may see probably there are OpenAI board tracer, right? So it may understand how to trick the game, how to maximize the score without playing the game in the right way. Self-driving cars. So if you set a goal, avoid the crashes, and it uh, it drives very slowly, it moves very slowly, or maybe it entirely stops. So it's achieving a goal, keeping you safe, but not in the right way. Cleaning a robo. So the goal is to reduce the mess. So it's throwing everything outside. It's throwing everything away. Or maybe it's pushing the dust under the carpet. Now it's achieving a goal what you have set, but not in the right way. So if you're not setting enough goals, the right goals, okay, if your goals are insufficient, you may see this kind of a reward hacking. The system may learn uh, the ways to achieve a goal, but not in the right way, not with the right intentions. Okay, so we discussed a lot of failures here. So Amazon's recruitment system, right? So here the root cause was the training data. So the training data was biased, and that created lack of fairness. The UCAS admission system, so it misinterpreted the diversity, and it created a ethical concern. The Google Photos, that failure was because of a poor data coverage. So since we did not have enough training data, or the training data was not diversified. The self-driving car, this failure was because of a contextual misinterpretation. So inadequate real-world simulation. So probably the system was not tested enough for the real-world simulations. The Apple Cart, it inherited the human biases, the co-relationship, though the gender was not one of the considerations, but it has identified the hidden biases in other attributes of a training data. The reward hacking will happen because the goals are misaligned and there is no validation of a reward function. So to overcome this, we should validate the reward function, and we should ensure that the reward function uh, is rewarding right with the right intentions, not just for the one goal, but achieving a goal with the right intentions. Now, we discussed a lot of failures here, and we know the quality characteristics as per the ISO 25010, right? So if you look into this traditional quality characteristics, none of this will help you to identify this kind of a failures. So whatever failures we discussed, it's not possible to identify even if we do testing for all these quality characteristics, what you see here. So what we need for uh, testing AI-based application is we should focus on these new quality characteristics. So you see, we have opportunities to test for a new type of test. So we should test for the autonomy. So we should see what are the limits for the system until which it can work autonomously. What are the limits if it goes beyond which it should transfer the control to the humans. Evolution. So AI-based systems are going to learn on its own. They're going to evolve. They may be learning the drift, and we should even test for this. The biases could be in the input data, the training data. The biases could be in the algorithm. Biases may also be introduced by the people who are developing the systems. The ethics, so the moral principles, right? So we should test the AI based applications, that whether they behave ethically correct or not. The social value should be respected. We should avoid the human harms, right? We should test for the side effects. So maybe you achieve one goal but you violate another goals, so that should not happen, right? So we should uh, test for unintentional or harmful side effects. The transparency, this is very important. The transparency, interpretability, explainability. So many times you would be wondering why this output, why this prediction. And yeah, to help you understand, the transparency is required. So transparency will help you to build the trust. Transparency will help you to uh, see the insight. Okay, so visibility will give you the transparency. Interpretability, so the output should be humanly understandable. And explainability, so the system should not just give you the predictions of just the results, okay, but it should tell you why this prediction. So there should be also enough explainability so that people can understand why this prediction. So if there is a loan prediction system, the loan application uh, system, so it should tell you why it is accepted or why it is rejected. So what was the reason for the rejection? Was it a credit score? Was it a monthly earning of that particular applicant? Okay, so it should tell you enough reasons why it was rejected or why that particular decision. And obviously we should also test for the safety. So the system should operate reliable, it should avoid causes of harm, and it should behave as expected even in uncertain situations. So you see a lot of new quality characteristics what we should test when we are testing an AI-based application. So along with those quality characteristics which are applicable for the traditional applications, we should also test these additional uh, quality characteristics. Okay, so here you see numbers, right? So you see the number of reported AI incidents. So this graph shows something very important. So over the last decade, you see that AI-related inconsistencies, the controversies have been increased, and this is not just technical failures. Okay, these are probably the biased recruitment systems, right? Unsafe autonomous systems, right? It could be also hallucinated information. It could be also discrepancy in the financial decisions. So it may also be misinformation. So AI system behaves in unexpected ways. So what is interesting is not only the number is increasing, but that many of these systems were considered successfully before the failures. So they passed the validation. They worked in demos. They appeared to be intelligent, and I think this is exactly why the AI testing becomes different from a traditional testing. So because the challenges is no longer only does the system works, the the challenge becomes, can the system be trusted under the real world circumstances, the in a real world uncertainty. So over the decade, we have been working uh, with some assumptions, right? And these assumptions are like, if we give the same input, the output will be the same. The expected results can be predicted, can be clearly defined. If the regression passes, the behavior is stable. More coverage means more confidence. But these assumptions are not gonna be true for when you're testing a AI-based applications. So they are not gonna be fully respected when you're testing AI-based applications. So traditional testing becomes very effective in the world when there is a fixed logic, when there is a predictive outputs, and uh, but when there is a deterministic behaviors. But when we are testing AI-based systems, it's gonna learn on its own. Okay, the systems are gonna learn from the data. They are gonna adapt for the context. They are gonna evolve over the time, and sometimes this produces a different output for the similar situations. And this means that the testing logic is no longer going to be effective. Okay, so what we should test is a behavior. And behavioral system introduce so sometimes testing was not just a fully designed for uncertainty, right? And this does not mean that the traditional testing becomes useless, but it does mean that some of our old assumptions start becoming less reliable when we are testing these applications. Here you see a ML model, the workflow. So you see, we start with setting up a objective. So unlike the traditional uh, applications where you get detailed requirements, here we start with setting a objective, which will be high level objective. And you see here, there are two different types of tests what are introduced here. One is preparing and testing a data. So testing a data becomes one of the test level, and testing the model when it's tuned and when it is built. So these are the two test levels we can say that which should be introduced when you're testing AI-based applications. So we should test for the input training data, and we should even test the model once it is built, once it is developed. So objective of input data testing is to ensure that the data used for the system for the training is of highest quality. So we should review the sources of the data. We should use statistical methods. We should do a exploratory data analysis. We use techniques like visualizing the data and finding a problems with the data, so that we ensure that whatever the training data we are providing is a quality data. And once the model is built for based on this training data, once it is evaluated and once it is fine-tuned, then we should do a model testing, which will ensure that uh, the model not learns well, but it performs efficiently, fairly, it performs transparently. So there are two new test levels which will be introduced here. Probably these are going to replace the component testing, right? So you see that the testing the data, the training data, and testing the model. Okay. So a few years ago, there was uh, researchers created an AI system to detect pneumonia from the chest scans. The model performed really well. Okay, it was with the highest accuracy. It had a strong confidence scores. Okay, good validation results. So everyone thought that the model understand the pneumonia, but later they discovered that, which was very strange. Okay, so they discovered that AI learned the to associate some type of X-ray machines uh, and with the severity of ill patients. So some hospitals used portable X-ray machines for uh, for uh, for severely sick peoples. Okay, and those machines left a certain visual artifacts or the marks on the images. So probably the text labels, the machine IDs, right? The image quality, because it was a portable X-ray machines, and these patterns the AI learned. So so instead of medically understanding what should be a pattern, it understood the pattern from these machines. Okay, so if the X-ray is taken from the portable machine, it started understanding that it's a positive for the pneumonia. Okay, and generally these portable machines are used for the people who are really sick, right, who can't visit the hospitals or the diagnostic centers. So these lung patterns indicate the pneumonia. So this should have been learned, but the images from the type of machine usually belong to very sick patient. So it learned as a pneumonia. So the model looked medically intelligent initially, right? While it learning something completely different. And then when I first read this story, I remember that, did the model fail? Or did the testing strategy fail here? Okay, so with that question, I wanted to leave you.
Mhm.
Do we, if we have any questions, I'm okay to take those.
Yeah, thank you very much for your presentation, Sagar. Really appreciate that you shared all your information here with us. And yes, sure, we have also some questions here. Uh, could the AI code also be biased?
Uh, See, okay, so inside the AI, so when you say AI code, I assume the models, right? So models, so there is no code as such. Yeah, there is a code, but we use algorithms, okay? And the algorithms may have a biases, okay, if we are not rightly configuring it. So when we are using the algorithms, the algorithm comes with a hyperparameters, and if we are not giving enough weightages to the parameters, then it may introduce a biases. Okay,
Mm,
so the biases could be introduced from three different sources. One is the input training data, the other could be the algorithm, and other could be the people who are developing these models. So these are the three sources of biases which can be introduced into a model.
mm, okay. Yeah, thank you. Thank you so much for the answering this. We have another question here. What skills should testers focus on developing now?
Okay, so that's a great question. Okay, so uh, even my intention of this presentation was to bring you or to showcase you what are the opportunities. Yes, there is a Gen AI, there is a lot of LLMs which you can use to optimize the testing efforts, but there is also other side of AI that we should so AI is becoming a complex systems, and to test this complex, there are a lot of other challenges which you see as a tester, and to ensure the quality, we see it as a challenges. And I'm not saying challenges as always a bad, but these challenges will bring you a lot of other opportunities. Now, talking about the skills, what we should develop, obviously the critical thinking, testing the behaviors, that's going to be more important. Just the coverage is not going to be enough. The tester should act as a trust engineers, and yeah, so that's gonna be very important shift in the role, that the tester should work as a trust engineers. So we should test the assumptions, and if you see the entire development of any system, the requirement engineering, the design, the implementation, and the testing. So testing would be the last where you wanted to remove the people from that.
Yeah.
Okay, because we develop the products for the people, and if the people are not validating it, it doesn't make sense.
Yeah.
Okay, so
Yeah.
you may introduce a AI, you may have agents, but the final evaluation, the acceptance should be by the human.
Yeah. Yeah.
So I still insist having those the basic fundamentals, the foundation, sticking to those, that the what we get from even the ISTQB Foundation curriculum. That's gonna be still valuable, even though you use a lot of AI and a lot of other tools. So there was a
Mm.
shift when there was a lot of automation. People start thinking that the automations are gonna replace the testers. That never happened. Even the same with the AI. Okay, so probably you should learn machine learning. Okay, even ISTQB has a AI tester curriculum, so that will make you future ready tester, because probably right now you might not be seeing AI based components in the applications what you are testing, but they're gonna come very soon. So
Mm.
the I feel ISTQB tester will give you enough knowledge about the model development, the machine learning, and what are the different type of tests. What I discussed in this session, you will learn to the more details. Along with, you'll also learn about data preparation and then exploratory data analysis kind of a techniques.
Mm.
Also, the test design technique like a metamorphic testing, back-to-back testing, adversarial testing, exploratory testing. So these are also going to be more important when you are testing something which is uncertain.
Mm. So much to learn for us as a tester,
Yeah.
yeah. And we have, I think, one final question here. How can we automate testing if outputs are probabilistic?
Okay. So automation is gonna matter here. Okay, so it's not gonna be outperform. Okay, but yeah, we need a different approach here as well. So we can't compare the explicit expected result. So probably we need some sort of a tolerances to be implemented. So when we are automating a test, we have to define the acceptable boundaries in the automation as well. And moreover, we need human oversight, even if we automate this test, okay, to validate, to verify. So we always need a human oversight here.
Mm.
So
Yeah.
automation is not going to be outdated here. Okay, it also still makes sense here, but the way we expect that we should have a concrete and the low-level test cases to go for the automation, that assumption is not going to be no longer going to be valid here. Okay, because
Mm.
you are not going to have those concrete expected results here.
Mm.
So we have to implement the tolerances in the automation as well.
Yeah. Yeah. Okay, thank you very much, Sagar, for this insights. I hope if anyone wants to connect with you, you are on LinkedIn, and you can
Yeah.
join the conversation there too. If you like the presentation from Sagar, just use the QR code here up front for voting the best presentation and best speaker award. And enjoy the rest of the program. Saga, I hope you can also join the rest of the conference program too and look into it.
I'm already
And
joining, but there is a lot of stuffs. So I feel I have enough things to go back and watch, at least for
yeah,
next few weeks.
yeah, it's enough for the next week to develop our skills for the future, as you said. So thank you very much that you were here. Have a good time and bye-bye.
Yeah. Thank you. Bye.